Hi everyone, this is Mr. Ruhoy, and this is an Algebra 2 video for completing the square. In this video, I'm going to show you two different applications for this method. The first application being that you can use this method to solve for the roots for a quadratic equation. The other application is that you can use this to take a quadratic equation in its standard form being ax squared plus bx plus c. You can take it from that form and rewrite it into vertex form. One very important thing I want to point out before we start is that completing the square only works for a quadratic equation where the leading coefficient a is 1. It only works if a is 1. If a isn't 1, what you would have to do then is divide both sides of the equation by GCF until a is 1. So let's take a look at our first example here. It says solve the equation, so the first thing we want to do is set y equal to 0. Because when we say we want to solve the equation, what we're really saying is we want to solve for the roots. And at a root, at a y-intercept, the y-coordinate, at the x-intercept, the y-coordinate is 0. So what we're doing is we're solving for x when y is 0. Now the first step in this completing the square process is to get x squared minus 8x by themselves. So we just want to add 5 to both sides of the equation. Next, what we want to do is we want to add a value to both sides of the equation. And that's going to come from taking b, dividing it by 2, and squaring it. Now in this problem, the value of b is negative 8. That would give us negative 4 squared, which is just a positive 16. So our next step is to add that 16 to both sides of the equation. Now there is a shortcut that you can use. I'm going to point it out in a couple steps, but I'm going to do it long ways first. But the shortcut is nice because it can save you a couple extra steps. But let's just continue with it this way. If we simplify the left side, we get 21. And what we want to do now is factor the right side of the equation. If you factor it, you get x minus 4 and x minus 4, which we can then just write as x minus 4 squared. Now the shortcut, while doing this process, is recognizing that the value of b divided by 2 is always going to be what we get after we factor. Minus 4 is what's always going to appear in the factors. So you can kind of just skip through the factoring process if you realize that. But what we have to do now is solve for x. We can do that by taking the square root of both sides of the equation. And don't forget to include the plus or minus in front of the radical. We always have to include that when we take the square root of both sides of an equation. Actually, I didn't really need to write those parentheses. But the next thing we want to do is finally get x by itself by adding both sides by 4. And there you have it. Now we solve for x. One thing you want to do before you call this your final answer is just to make sure that you can't simplify the radical any further. In this case, there are no factors of 21 that are perfect squares. So I believe this is the most simplified our answer can be. If we take a look at our second example, if you notice, we have for the leading coefficient of a, it's not 1 in this case, it's a 3. So we're going to have to find a GCF. What I would like to do first is just bring all the terms over to one side of the equation. So if I subtract 2x from both sides, I get 6x, positive 9, equal to 0. And then what you can do is you can factor out a GCF of 3. Oops. And we can divide both sides of the equation by that. And we get x squared plus 2x plus 3. dividing out a GCF does not change what the roots are going to be. So now that the leading coefficient of a is 1, we can begin our completing the square process. What we want to do first is get the x squared and the 2x by themselves. And then we want to add b divided by 2 squared to both sides of the equation. So the value of b is 2. So that's 1 squared and just 1. So we can add 1 to both sides of the equation. And then we can factor this. This we can just write as x plus 1 squared equal to negative 2. And if you remember the shortcut I mentioned, if you recognize that the value of b divided by 2 is what's going to appear inside the factors, then that can save you the step of having to actually go through the factoring process. B divided by 2 is always what you're going to get as a result of factoring. Now to finish this off, we need to solve for x, so we want to take the square root of both sides of the equation. So we get x plus 1 equals plus or minus rad negative 2. And we can subtract 1 from both sides of the equation. And now, looking at it, this is not an acceptable final answer. It's not proper to leave a negative under the radical. So what we want to do is, I'll do it step by step. We want to write this as rad negative 1 times rad 2. And the square root of negative 1 can be written as I. And there we go. And that is our final answer. Now, last problem that I have here is rewriting the quadratic equation in vertex form. Now, we only need to modify our completing the square process just a little bit. The only difference really is that instead of substituting in a 0 for y, we're just going to leave y as it is, leave it in the equation. But we're going to add 1 to both sides because, like before, we want to get the x squared and the minus 4x by themselves first. And then we're going to continue with the same process as we used before. Add b divided by 2 squared to both sides of the equation. That's going to be negative 2 squared, which is a positive 4. So we want to add positive 4 to both sides of the equation. If we simplify it, we get y plus 5. And if we factor, we get x minus 2 and x minus 2. We can write that as x plus 5 equals x minus 2 squared. And if you like using a little shortcut that I showed you, b divided by 2, which gives you a negative 2. That's what you end up with inside the factors here. So you could skip over the factoring process, recognizing that b divided by 2 is what you get inside the factors. Our last step is to get y by itself. And now we have written this in vertex form. Just to remind you, vertex form is a x minus h squared plus k. And the vertex of this parabola is the value of h and k, following this definition. So if we want to figure out what the vertex is, we would look at the value inside the parentheses. You see you have a negative 2 there, so that means that the value of h is a positive 2. So we go from a negative 2, we're going to change the sign, make it a positive 2. And then inside the parenthesis, the value of k is 5. And that's our vertex. And the reason we switch the sign from the -2 to a +2 is that if you recall, anytime you're doing a horizontal translation onto a parent function, when you add inside the parentheses, that shifts it to the left, and when you subtract, that moves it to the right. And this is our x-coordinates, so that's the horizontal translation. So inside the parentheses, we have to change the sign, but then the k value, that's the vertical translation. That's as it is. And I just realized that that should be a -5. I really apologize if that confused anyone. Yeah, so that is definitely correct now. I'm glad I caught that. So that is our video here. I really hope that helped. Thank you for watching. Take care. Bye-bye.